Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, guys, so for this video, I will discuss some of the problem at the fundamental of physics. This is a sample problem 14.03. It's about dynamic fluid, it's about fluids. And I think this is the sample problem from the book, and I think it will be interesting to discuss this question. uh, Actually, in the book itself there is the result, there is the answer for this question. So this question actually has been answered by the book, and there is a step to answer it, there's a step to solve the question, but I think it would be much better if I explain it to you, because of course maybe only 40 or 50% of people who understand how to solve it just by reading it. So I think it's interesting to discuss it directly using video. So let's discuss the question. The question are the YouTube in figure 14.4. This is the figure, contains two liquids in a static equilibrium. The water of the density of the water is 998 kilogram meter square per meter square, is in the right arm. So this is water, this is oil. And oil of unknown density of rho x. So the density of this, we call it rho x, is in the left. Measurement gives L, this is L, the length of L is equal to 135 millimeter, and D is 12.3 millimeter. What is the density of the oil? So we need to find the density of the oil. So what is the law that we will use in this kind of problem? So there is a law in hydrostatic that stating that 2 point in a straight line, both of the point will have same pressure, hydrostatic pressure. So for example, if we use this point and this point, which is in a straight line, of course, see, it is in a straight line, these 2 point will have same hydrostatic pressure. It's not, so just by the position of the point, the position of this 2 point in a straight line, we could simplify, we could take a conclusion, I'm sorry, conclusion that this 2 point have a same pressure. So that is an hydrostatic law. Okay, hydrostatic law. uh So we could stating that, just call it this point A, and this is point B. So point A and point B have the same hydrostatic pressure. So let's answer it. Okay, let's answer it. So hydrostatic pressure at point A will be just the same at the hydrostatic pressure at B. So we could, of course, from using the equation, pH, hydrostatic pressure is equal to rho, the density of the fluid, times G time H, which is the depth of the fluid. We could change it to rho A, the rho at the point A, times G times HA, equal to rho B times G times HB. Of course, because G is always the same, it's a constant, so we could remove this from the equation. So what left in the equation are rho A times HA is equal to rho B times HB. So what is rho A? Rho A, look at this point, what is the fluid at this point A? Of course, the fluid of this at this point is the oil. So we use the density of the oil, which is we don't know about it. But we call it earlier. It is rho x. It is what we are trying to find. So what is HA? HA is the height, the depth of this point from the surface of the fluid. Surface of the fluid is oil is the fluid, and the surface of the oil is this is there. So we need to calculate what is the length of this. What is the length of this? Now, the length of this is from the figure. We could uh, take take a conclusion. The HA, the height, the depth of this point A is just equal to L times D. L times D. Okay. Now, what is equal to rho B? Rho B, what is the rho B? What is the fluid of this point B? Which, of course, it's water. So it's the rho of water. So we use the rho of water times HB. HB is the from the surface of the water to the point, which is equal to L. So we could change this to L. So to find rho x, because what we want to find is the rho x is equal to rho of the water times L per L plus D. So the rest of this is the mathematics. So I think we just insert the value that we have that we had in the question. Just insert the data. So what is the row of the water? 998 times L. What is L? L is 135 millimeter. Okay, because in the density we use the unit kilogram per meter cubic, so we use metric units here. So we need to change the millimeter to meter. So the L is equal to 135 millimeter. It is just the same as 135 times 10 10's point 3, I think, meter. I'm sorry. There is a little disturbance, I think. Okay, let's just continue the our discussion. So 135 millimeter to meter, we know it. It's 135 times 10 to the power of minus 3, because from meter it's up it's up three times. So 135 times 10 to the power of minus 3 meter. We know that D is equal to 12.3 millimeter, which just the same, we change it to the meter. 12.3 times 10 to the power of minus 3 meter. Okay. Okay, so let's insert it to the equation. 998 times 135, 10 times 10.3 per divided by L, which is 135 times 10.3 plus 12.3 times 10 to the power of minus 3. So rho x is equal to 998 times 135 times 10 to the power of 3 minus 3. So the 10 to the power of minus 3, we could getting that out from this. So it is just equal to 10 to the power of minus 3 times 135 plus 12.3. 10 to the power, this we could erase it, we could divide it, and this just leave us 1. So rho x is equal to 998 times 135 divided by 135 plus 12.3. This is 150. I'm sorry, 100, 147.3. 100 147.3. Okay. Okay, so we have this, and using calculator, you could calculate it. This is equal to rho x is equal to 914, comma 66395, and we could approximate this value to rho x is equal to 915 kilogram per meter squared. So per meter cubic, I'm sorry, meter cubic. So this is meter cubic. So this is the answer. So this is the density of the oil. Okay. I think this is the discussion, the end of the discussion. I hope you could understand this problem with my discussion here. Thank you for watching my video. Don't forget to like, subscribe, comment, and subscribe. Okay. Thank you. Assalamualaikum warahmatullahi wabarakatuh.